In this video, we're going to create a fine-tuned data set using a PDF as a data source. So the video will be broken down into three main sections. We can prepare a data source. We can use a local LLM of our choice. We can use Llama 3.1, and then we can create an end generation using Llama or Llama model to create our data set. Now, the data set will look something along the lines of this. So this is a JSON lines over here. So we have a user, we have an assistant response, and many others. This actually took inspiration from the OpenAI documentation. So you have a messages JSON, and it has a list where you have a system prompt and then a user prompt, something that you ask a question with. And then you have the assistant that gives us the final answer. By the way, I make similar videos like these on LLMs, machine learning, and other data science tools. So please feel free to subscribe. Now, we will be taking a PDF as a data source to create a custom data set. Now, the reason why I'm doing this is because right now I'm trying to fine tune my own LLM for my own use case, where I actually have a lot of data stored in a PDF, which I have to convert it into a question answer to give me correct generation at the end. So let's get on with it. And before we start diving inside the code, let's actually download our model. So what you guys have to do is you have to copy this command. Well, first of all, you have to download the Llama package in your computer. It's actually very, very simple. It's a terminal-based application. Once you download that, we're going to copy this command, Llama run Llama 3.1, go to our terminal and run Llama run Llama 3.1. Now I've already downloaded Llama 3.1 in the computer, so I'm just going to skip this as well. So the first thing that I'm going to do is I'm going to extract data from the PDFs. Now, of course, this will look different to what you are doing from your data source. So in this case, I have to install PyMu PDF and Llama as a package. After we've done that, we can import it. And then I have this nice function where I have made to export the PDF or each page from a PDF. Now, of course, taking help from ChatGPT to make my life a bit more easier. And the way I use it is I pass in this PDF path and then I extract the text. So the text data, if you look at one index of it, by the way, this is a list that I have. So each of it has an entire page of information stored inside of it, which we can use as a context to generate some question answers. And then now we have a parsing function. So this is a function that I've made based upon the output of the LLM. Now, before we do that, we have a question answering pair. This is the list where we're going to save our data, where it's going to have a user prompt and a assistant prompt. We're going to have a counter, so how many attempts were made and how many failed generations, because sometimes the LLMs may or may not give out the correct generations. We want to see how many of that. Now we're going to create a function to parse the information from the LLM. Now this function over here may not make a lot of sense. And that's because this is something that you guys have to do it yourself for your own data. So whenever I get a response from the LLM, I'm going to show you guys later on how it looks like. I get a question and an answer that starts like this. It's a string that starts like this, question, and then answer from the LLM. I don't know why it answers in this format, but I guess this is something that the Llama 3.1 model behaves. So we do some basic regex or string manipulation, and then we create a JSON over here that has a user and an assistant, and then wraps it around the JSON object. We pass it into a question list, and then we do some counter. Plus, if it did not successfully parse out anything, we just increase the failed generation. Now, again, this is going to make much more sense when we start generating the questions. Now we get to make our inference loop. So this loop, the main idea of this loop is that we are simply going to take the context from each of these PDF pages that we have over here, and then tell the model to make us a user question and a user answer for this specific page. And we're going to loop through every single page in the PDF and generate a corresponding question answer. So a very basic idea in that sense. So we just import Llama over here. We can define a for loop. And in the for loop, we will essentially get the page text when we're looping through the PDFs. We're going to start from 5 because the first couple of pages are just table of content. We're going to pass in the Llama chat, or we're going to pass in the context in the Llama chat. So it has 3 main prompts over here. For 3 of them are user prompts. First, we have the user prompt, make up a coding question answer. And then the next one is based upon this context. Now this context is the same context when we're looping through the PDFs. So it has some idea of what we're searching for. And then at the end, have standardized sections like question and answer. Now this is something that you guys can write on how you guys want to have it. but this is how I've prompted it to write it. So which is going to help us to parse the information when we have it over here. Over here. And I'm going to show you guys an example of how the prompt looks like in at least one of the iterations, just to kind of give you guys an example. So we're going to get the results from the response that we get. So we're going to parse out the response that we get from here, and then we pass it to the function that we've created earlier. And then we're going to see if the results is not none, which is if it's not none type, we're going to pass it onto the list that we've defined earlier in our notebook, and we're going to print the results. And this is done as an extra cautionary step. So if in case, or there was one instance where I tried it where it did not generate properly and give me a none type for some reason. So if it does happen, it doesn't happen that often, but if it does happen, we're going to skip that. But other than that, we're going to append it to our QA pair list. And then we're going to have some counter. Now this counter is of course optional, but this is something that I like to have personally. Now we can also going to quickly do some logging. So write how the result looks like as it is, just to see how the response typically looks like. So I'm going to put some extra stuff over here to make it easier to read. And for the counter, we can have 3. And now we can run it. Actually, there's one small thing that I missed to do. Instead of Llama 3, it's supposed to be Llama 3.1. Sorry about that. So let's fix that and run again. Okay, so now it's currently generating data. So the answers look like this. You have question, you have answers, and then you have a Python code. And this is one question answer pair. And then the function that we have made over here takes out the information from here and converts it into a JSON, which we can use to make our fine-tuned data set. And now this parsing operation will be different to your use case based upon how different your data looks. If your data doesn't have like question answer like this, then you may have to do some, or may have to use some creativity to fix that function. But nevertheless, that's how you could do it. And now I change it to 2 question answer pair to generate to keep the tutorial short. So here we have 2 JSONs over here. And now what we're going to do, we're going to save this data into a JSON file. So we're going to create a file path, JSON, data.json.out. JSON.out is the data format you need to save it in order to train an LLM like OpenAI model or any other model. It's really up to you. But nonetheless, we open a file and then we just dump the items from our QA pair list. And now if we inspect our JSON.out function or the file, we should see some data. And here we go. Here we see some JSON with our user prompt and our assistant prompt that we get. And there you guys have it. That is how you can use a local LLM like Llama 3.1 to create data so you can save it and train and fine-tune your model. All right, guys, hope you found this video insightful. If you guys did, please feel free to subscribe. I make similar videos like these. All right, guys, I hope to see you in my next video. Have a nice day.